You know that thought you had when you were like 8 years old, digging in the backyard? If I keep going, will I end up in China? Well, turns out you probably wouldn't pop out in China. But that's beside the point. Today, we're gonna actually figure out what would happen if you could drill a hole straight through the entire planet and jump in. And I'm talking all the way through, not just down a few miles. I mean 8,000 miles of tunnel, right through the middle, out the other side. Sounds simple, right? Just drill down and keep going. Yeah, about that. So first off, could we even do it? Let me just say this up front. We can't. Like, not even close. The deepest hole humans have ever made is in Russia. It's called the Kola Super Deep Borehole, and it goes down about 7.5 miles. That sounds pretty deep until you realize Earth's radius is almost 4,000 miles. We barely scratched the surface, literally. And even getting that far took decades. The drill kept breaking, the rock got hotter and hotter. At the bottom of that hole, temperatures hit around 600 degrees Fahrenheit. The pressure was 4,000 times what you feel standing at sea level. Now imagine going another 3,990 miles deeper, through temperatures that reach 9,000 degrees, through pressures that would crush pretty much anything we know how to build. Here's what you'd be drilling through. First, there's the crust, which is like Earth's skin. It's only about 3 to 60 miles thick, depending on where you drill. Under the ocean, it's thinner. On land, it's thicker, but either way, that's the easy part. Below that is the mantle. This thing is almost 1,800 miles thick. It's not quite liquid, not quite solid. Think of it like really, really thick caramel that flows super slowly. The temperature starts at around 1,300 degrees Celsius and climbs to 4,000 degrees as you go deeper. Then you hit the outer core. Liquid, iron and nickel flowing around, creating Earth's magnetic field. Temperature, about 4,000 to 6,000 degrees Celsius. That's as hot as the surface of the sun. And right in the middle, the inner core. Solid metal. But only because the pressure is so intense that even at those crazy temperatures, the atoms get squeezed so tight they can't move around as a liquid. To drill through all this, you'd need a material that doesn't melt at temperatures hotter than the sun and doesn't get crushed under millions of pounds of pressure. Scientists have looked into this. Diamond can do it. Even custom materials made with hafnium, nitrogen, and carbon can only handle about 7,460 degrees Fahrenheit. That barely gets you to the edge of the core. And here's another problem nobody thinks about. The hole would try to close itself. Without constant pressure from drilling fluid, the walls would just cave in from all that weight pushing on them. The deeper you go, the more the planet wants to squeeze that hole shut. So yeah, we're not drilling through Earth anytime soon. But okay, let's pretend we somehow did it. Let's say future humans figured it out. We've got some magic material, we pumped the hole full of something to keep it from collapsing, and boom, there's a tunnel straight through the planet. What now? Well, if you're brave enough to jump in, things get weird fast. First problem, you're gonna die immediately. Sorry. At just over half a mile down, you'd hit temperatures around 140 degrees Fahrenheit. You'd die of heat stroke. A bit further and your blood starts boiling. By the time you're 120 miles down, you've been incinerated into dust. But let's say you've got a crazy advanced heat suit. Some futuristic thing that protects you from heat, pressure, toxic gases, radiation, all of it. Now what? Well, now you've got the rotation problem. See, Earth spins, and different parts spin at different speeds. At the equator, the surface is moving at about 1,000 miles per hour. But the deeper you go toward the center, the slower things are moving, because there's less distance to cover in the same 24 hours. So when you jump into the hole, you're moving sideways at 1,000 miles per hour, but halfway down, the walls around you are moving slower. You'd smash into the side of the tunnel like you got hit by a car, game over. The only way around this is to drill from pole to pole instead of through the equator. At the poles, there's basically no sideways rotation, so you wouldn't get thrown into the walls. Let's say we did that, okay? You jump in. At first, gravity pulls you down like normal. You accelerate, going faster and faster, but here's where it gets interesting. As you fall deeper, there's less and less earth beneath you pulling you down. Because of something called the shell theorem, all the rock that's now above you doesn't pull you toward the center anymore. It cancels itself out. So you keep accelerating, but the acceleration gets weaker the closer you get to the center. By the time you reach the middle of Earth, gravity is zero. There's equal amounts of mass in every direction around you, so the pulls cancel out. You are just floating there, except you're not gonna stop. Because you've been falling for over 20 minutes at this point, and you've built up a ton of speed. Scientists calculated you'd be going around 22,000 miles per hour at the center. So you overshoot, you keep going up the other side, but now gravity is pulling you backward, slowing you down. And because this whole setup is basically a perfect physics problem, you slow down at exactly the right rate. Right as you pop out the other side of Earth, your speed hits zero. The whole trip takes about 42 minutes. Wait, 42 minutes? That's oddly specific. And yeah, it gets weirder. But back to that in a bit. Here's the thing. You are not just gonna pop out and stop. Unless someone's waiting to grab you, you're falling right back in. You'd oscillate back and forth, shooting through the tunnel over and over again, like a really weird pendulum. In theory, without any air resistance, you'd do this forever. But we live in the real world. Even if the tunnel was there, you'd have air in it, and air resistance would slow you down a little bit each pass. Eventually, you'd end up stuck, floating at Earth's center, which honestly sounds like a nightmare. But wait, we forgot the air. If the tunnel isn't a complete vacuum, you've got a whole new problem. See, air pressure gets way higher the deeper you go. Every 10 feet of rock equals about 1 atmosphere of pressure at sea level. By the time you're a few hundred miles down, the air in the tunnel would be so dense it'd basically be liquid. You wouldn't be falling through air anymore. You'd be swimming through soup. Or more like trying to move through honey. You'd slow down so much, you might not even make it to the other side. You'd just get stuck partway through, floating in super dense air. This is actually why scientists say if you wanted to do this for real, you'd have to pump all the air out, make it a vacuum, no air resistance, smooth ride, 42 minutes from one side to the other, of course. Now you need a spacesuit because there's no air to breathe, but hey, you already needed the crazy heat suit anyway. But there is a bigger problem nobody talks about. Earth's core is what creates our magnetic field. That magnetic field is what protects us from solar radiation. Without it, the sun would basically strip away our atmosphere and sterilize the surface. To make this tunnel, you'd have to punch through the core. You'd be messing with all that flowing liquid metal that generates the field. And honestly, you'd probably destroy Earth's ability to support life in the process. So, congratulations. You build your tunnel. You also kill the planet. This is why this is all just a thought experiment. It's fun to think about, but in reality, it's not happening. We can build it, we can survive it, and even if we could, we probably shouldn't. So, what's the point? Look, we're never gonna drill through Earth, but thinking about it teaches us a lot. It shows us how extreme conditions get inside our planet, how gravity actually works when you're inside a massive object instead of on its surface, how air pressure scales with depth, how orbital mechanics and oscillations connect to everyday motion. This is what physics is really about, taking impossible scenarios and working through them to understand the rules of how the universe operates. You learn way more from asking what if we drilled through Earth than you do from just memorizing that gravity equals 9.8 meters per second squared. Plus, it's just cool to know that if you somehow did it and jumped in, you'd pop out on the other side in exactly 42 minutes. The answer to life, the universe, and everything. Maybe Douglas Adams was onto something. Anyway, that's what happens if you drill a hole through Earth. You can't, you die, the planet would die, but the physics is awesome. Thanks for watching.